All right, some other characteristics. First, some vocabulary. Muscles can move in a variety of ways. Okay, when we think of muscle activity, the first thing we think of is a muscle shortening, right, where it gets smaller. In other words, it moves a bone. If you're going to move a bone, a muscle has gotten longer and shorter, both. But there are other ways that muscles can move. So we have isotonic and isometric. Isotonic contraction is you have the same weight in two muscles, right? In other words, the same pressure, but the length changes, right? So the muscle actually shortens. So this is moving our bones around, right? The other is isometrics. This is where a muscle is imparting force but isn't changing length, okay? Classic example of this is yoga, right? Where you keep a muscle contracted for a period of time. No, nothing's moving, nothing is shortening or lengthening, but definitely energy is being spent, right? So you've got isotonic and isometric, different ways that all muscles can move. Every activity is a combination of the two things, right? Because ultimately we have to support our body weight, that's isometrics, and we have to move around, that's isotonics. Now, not all muscles have the same characteristics. Different muscles have different purposes, and because of that, they have different reactions. So some muscles, we have fast twitch fibers and slow twitch fibers. Fast twitch fibers do what their name suggests. They're very quick to contract and therefore very responsive. Okay, so like fast twitch fibers are great in parts of the body that move quickly but don't have to exert a ton of force for a long time, right? So think like your eye muscles, right? Your ocular muscles respond very quickly, but it's not like they're holding anything heavy, right? So the fast twitch fibers are rapid contractors, and they can generate a fair bit of force, but not for very long. Another example of a fast twitch fiber is your gastrocnemius muscle, your jumping muscle, right? It can contract fast enough and hard enough that it can lift your body up off the ground, but it can't maintain that for long periods of time. A slow twitch fiber is slow to contract, but it has the ability to maintain that contraction for much longer periods of time, right? So the one of the great differences in the calf is you have two muscles that look very similar but have very different purposes in our human existence. The soleus muscle is like our walking, standing muscle, right? It's a slow twitch muscle. It can work all day and not complain, right? Then you have the gastrocnemius, which is our jumping muscle, and it can throw us up into the air, but it can't maintain that tension for long periods of time. Another place that's very relevant to you right now that you're going to see slow twitch fibers is in the muscles of the back, right? The postural muscles are slow twitch muscles because literally they're contracting all day long, 18 hours a day. So they don't contract real fast, but they can do so for a long time. As you're looking at your donor tissues, look at the difference. Like you can visually see the difference between slow twitch fibers, like a muscle that's heavy and slow twitch versus a muscle that's heavy and fast twitch. So you'll be able to see the difference as we go. The slow twitch fibers, they tend to have smaller fascicles, but many, many more of them. So you'll see they have sort of a different look to them. Like compare what the trapezius looks like, right, to what the spinal, what do you call those? The spinal extenders. Yes, the erector spinae muscles, yes. And you'll see the difference that I'm talking about.